Hello everyone, my name is Han Shengxiang and this is question 10 of homework 8 in the probability and stochastic process course. And in this question, we want to show if the normal process is the white sign stationary so that it is a strict sense stationary. So we want to prove that because of the we could set the xt is white sense stationary, and we wish to prove it is a strict sense stationary so that the density function of x1 x2 xn for the xt t1 t2 tn is equals to the time shift for any n and epsilon, so the time shift is not influence the density function. It is the strict sense stationary property, and in this condition, we just know the xt is white sense stationary. We could know that the density function of xt is depend on the ti minus the x ti minus the tj, and xt is a normal process, so the density function of the xt is could set it as a normal process function xn t1 t2 the tn is equals to the 1 over the square root of 2 pi and the n square root to the delta c and the times the e to the power of minus 1 over 2 times x minus eta. It's transform matrix, and times the C inverse matrix, and times the x minus eta. And to in this function, we want to compute the C. The C in this is equals to expected value of x minus eta and times the x minus eta, its transform matrix, and it's equals to x minus eta xt1 minus expected value of xt1, and it is equals to eta, and and xtn minus the expected value of xtn, it is the x minus eta matrix, and times the transform matrix of it is equals to xt1 minus expected value of xt1 and xtn minus expected value of xtn. And to compute this matrix, and this matrix we could compute it for the the n to n matrix, and the first element is equals to these two times, and it is equals to expected value of xt1 times xt1, and this is eta minus eta xt1 minus eta xt1, and plus the eta to the power of 2, and expected value of this is r t1, and it is equals to eta to the power of 2, so the first element is equals to rt1 minus eta to the power of 2, and so on, the rt1 tn minus eta to the power of 2, and this is also the rt1 tn minus eta to the power of 2, and Tn minus eta to the power of 2. For this line of the matrix, the Rt1 is equals to R0. It is equal to R0 minus eta to the power of 2, and Rt1 Tn minus the power eta to the power of 2, and this is also the It1 Tn minus power of 2, and it is R0 minus power eta to the power of 2. So this matrix, we could write it as the covariance of the T1 minus T2 and T1 minus T3 in this array, a row, and for all the elements expect of this line, because it is R0 minus eta to the power of 2, and so it is the last is Tn minus 1 is equal minus the Tn, and it is equals to the covariance of Ti minus Tj for any I not equals to j, and ij is from 1 to n, and we could write it as this. So the density function of the xt is equals to xt. The density function of xt is equals to this form, the Ti minus Tj for I equals to j, and ij is from 1 to n. Because of the WSS property, it only depends on the time shift, and this, when the time shift, we could write it as the t plus the epsilon. Sorry, it's not plus. T2 plus epsilon and the Tn plus epsilon, and it is equals to this form. We could write it as the Ti minus epsilon minus times epsilon minus the Tj times epsilon, and for any I is not equals to j, for any I j is equal to 1 to n, and it is equals to this part. Ij is equals to 1 to, so it is for when we write it as this part, because of the normal process, it is equals to the density function of xt. So it is equals to the density function of the original fxt. So we could prove that the time shift could not influence the density function of the xt, so it is the street sense stationary. That's all. Thank you.